Welcome back to CloudOps Lab. This is episode 2 of the DevOps Foundation series. In episode 1, we explained what a CI/CD pipeline is and why it matters. In this episode, we are going one level deeper. We are going to build the mental model for a real GitHub Actions pipeline. The goal is simple. Every time someone opens a pull request, the pipeline should check the code automatically. When code is merged into the main branch, the pipeline should be ready to build the application. You do not need to memorize every YAML option today. What matters is understanding the structure, because once you understand the structure, every workflow file becomes much easier to read. A GitHub Actions pipeline usually lives inside your repository under a folder called .github/workflows. Inside that folder, you create a YAML file, for example, ci.yml. That file answers 4 questions. First, what is the workflow called? Second, when should it run? Third, what jobs should it perform? Fourth, what steps happen inside each job? Let us start with the workflow name. At the top of the file, you might write name:"CI pipeline." This is the label you see in the GitHub Actions tab. It does not run anything by itself, but it helps humans understand what the workflow is for. Next comes the trigger. In GitHub Actions, the trigger is usually defined with the word on. For a beginner CI pipeline, you might run the workflow on pull requests and on pushes to the main branch. That means GitHub automatically starts the pipeline when a developer opens a pull request or updates the main branch. This is already powerful. You no longer need to ask, did someone run the tests? GitHub runs them for you. After the trigger, you define jobs. A job is a group of steps that runs on a machine called a runner. For example, you might have a job called test. That job could run on Ubuntu latest, which gives you a clean Linux environment in the cloud. The word clean is important. If code only works on your laptop, that is not enough. The pipeline proves the project can run from a fresh environment. Inside the job, you define steps. Steps are the actual commands or reusable actions that run in order. The first common step is checking out the repository. GitHub provides a reusable action called actions/checkout. This downloads your code into the runner so the pipeline can work with it. The second common step is setting up the runtime. If you're building a Node app, you might set up Node. If you're building a Python app, you might set up Python. If you're building Java, you might set up a JDK. The third step is installing dependencies. For Node, this might be npm CI. For Python, it might be pip install. For JavaScript projects, npm CI is usually better than npm install in CI because it uses the lock file and produces more repeatable builds. The fourth step is running quality checks. This might include linting, formatting checks, type checks, or security scanning. The fifth step is running tests. A simple command might be npm test. In a real project, you might split fast unit tests from slower integration tests. If any step fails, the job fails. If the job fails, the workflow fails. That failure becomes visible in the pull request. This is exactly what you want. A failing pipeline is not an annoyance, it is a safety system.
Now imagine the pull request view. Instead of relying only on human review, the reviewer can see that the code builds and tests passed. That gives the team more confidence before merging. Once the simple CI pipeline works, you can add a build job. The build job might run after the test job. It might compile the app, generate production files, or build a Docker image. For a Docker workflow, the steps might log into a container registry, build an image, tag it with the commit SHA, and push it to the registry. The commit SHA is useful because it makes every artifact traceable. You can ask, which exact commit produced this image? The tag gives you the answer. This is where beginner pipelines start becoming real DevOps pipelines. You are not just checking code anymore. You are producing a deployable artifact. Here is the basic flow to remember. Pull request opens, run lint and tests, merge to main, build the app, package the app, store the artifact, then deploy that same artifact. Notice again, build once, promote the same artifact. Now let us talk about secrets. Many workflows need tokens, cloud credentials, or registry passwords. Never paste those directly into your YAML file. In GitHub, use repository secrets or environment secrets, then reference them in the workflow. This keeps credentials out of source control. Another important concept is permissions. A workflow should only receive the permissions it needs. If a workflow only reads code and runs tests, it does not need broad write access. Start small, make the pipeline pass, then tighten and improve it. The most common beginner mistake is trying to build the perfect pipeline on day one. Do not do that. Start with one workflow. Make it run on pull requests, check out the code, set up the runtime, install dependencies, run tests, then add linting, then add build, then add Docker, then add deployment to staging. That path gives you confidence without overwhelming the project. Before we finish, here's a simple checklist for your first GitHub Actions workflow. create.github/workflows/ci.yml. Add a clear workflow name. Trigger it on pull requests and pushes to main. Use Ubuntu latest as the runner. Check out the repository. Set up your runtime. Install dependencies. Run linting or formatting checks. Run tests. Add a build step. Once those steps are green, your repository has a real CI foundation. In the next episode, we will Dockerize an application so the same app can run consistently on your laptop, in CI, and in the cloud. If this helped, subscribe to CloudOps Lab and comment Actions if you want a downloadable starter GitHub Actions workflow. The goal is not to make CI/CD complicated. The goal is to make every change easier to trust.